Okay, so if P, then Q. So what that means is that P leads a Q. P leads. So a good example. I mean, I'm not that old, but if I were 7 years old, then I can collect Social Security. Okay, that's probably your grandparents' age, right? Um, so if you're a certain age, or another good example, if you're 16, then I could drive a car. You're legally able to drive a car if you're 16, right? So that's what's meant by conditional statements. If this, then there's a conclusion. So P is hypothesis, Q is a conclusion. So if you're a student in this class, then you're a student at Sacred Heart Prep. Obviously, there are no Menlo students or Cassidy students or Woodside students or MA students here, right? We're all SHP students, right? So from a mathematical perspective, if B is between A and C, then AB plus BC equals AC. There you go. That's an if-then statement. So there's a few ways you could write. You could just say if P, then Q. P implies Q, or Q if P. So for example, if it is raining, then it's cloudy. Rain implies cloudiness. It is cloudy if it rains. So those are all conditional statements. So really, there's nothing much to write down for this. It's more just know it. It's kind of laying the groundwork for the rest of the unit. Converse. Converse when you do a switch. So you totally do a switch. That's a converse. Um, so okay, obviously, this is the last teacher, Ms. York. If you are Ms. York, then you like chips. Okay, well, let's say Mr. E, because and I do love chips and salsa. I also like guac too. We had chips and salsa for lunch today. So if you're Mr. E, then you like chips and salsa. So what's a converse? Now this is gonna be weird. If you no, it's not do not. That's an inverse.
If you like chips and salsa, then you
But that's not. But okay, who in this room likes chips and salsa? Yeah, most of you guys. Yeah, you guys are normal. Good. Okay, James, are you Mr. E? No, you're not Mr. E. You're not Mr. E. You're not me, right? You're James Thomas, right? So,
Peace, bro. Your Eddie says about right. No,
so the answer is no.
you're a missus.
So converses are not necessarily true. I know this gets pretty silly. Here's another one. Who lives in Atherton in this room? Okay, you live in Atherton, great. So you're a San Mateo County resident, right? So if I were to say, if you live in Atherton, then you're a San Mateo County resident. That's true, right? Because Atherton is San Mateo County. Now, does someone live in Redwood City in this room? Okay, great. So let's reverse it. If you're a San Mateo County resident, you live in Atherton?
That's not true.
Not true, because you could be in Redwood City, you could be in San Mateo, you could be in Burlingame, you could be in Portola. No, Portola Valley is actually Santa Clara County. But you could be in a lot of different areas, right? So actually, Menlo Park is also San Mateo County. So yeah, so that's not necessarily true. So keep that in mind. Okay, let's keep on moving. Okay, more counterexamples. All right. Example of Phil's hypothesis, but not the conclusion. Okay, so for the statement above, so for example, counterexample is that James, I know we have two James, so let's use James T loves chips and salsa, but he is not Mr. E. So that's a counterexample. So for example, if 4x minus 5 equals 15, then x equals 5. What's the converse? If x equals 5, I mean, it's true. It's true. So sometimes it could work. So that is true. But and that should be an equal sign, by the way. So what's the converse here? Correct, right? If x squared equals 16, then x equals 4. Is the converse true? Not necessarily.
Wait, it's minus 60.
It's supposed to be equals. It's a typo. X could equal -4. Yeah, go ahead. Of course, yeah. X could equal -4. So let's just pause a little bit because I know I'm going a little fast. So again, converse sometimes are true, sometimes they're not true. It depends. Or another good example we could say is I think a good example of sports might be George Kittle plays for 49. No. If you play for the 49ers, then you're in the NFC West. That's true. If you're in the NFC West, you play for the 49ers?
No.
No, because you could play for the Rams, Seahawks, or Cardinals, right? So yeah. So again, it could be or cannot be. So that's what you have to keep my converse. So hopefully that makes sense with that one. And this is just like more laying the groundwork for stuff we'll do later in this unit. Okay, we're good.
Question. No, not necessarily.
You could say false if you want, because it's not true all the time. Or you can say sometimes if you want. That could work too. All right. All right, let's keep moving. Okay, biconditional. That's when it goes back and forth. So the converse would also be true. So they both work. So angles are congruent if only if their measures are equal. So that's true. Because you could say if angle measures are equal, then they're congruent. Also, you could say if angle measures are congruent, then they're equal. And by the way, the double quotation means I'm just repeating the previous statement. I don't feel like writing that over again. So when both sides work, when you reverse it, we call that a biconditional. And definitions can always be constructed as biconditionals. So before we do that, does that make sense what we're trying to do here? So again, it's just saying if P leads a Q, Q also leads a P. So for example, I don't know, I'm trying to think of good example. I can't think of good examples right now, but we'll do math examples. So midpoint. What's the definition of midpoint? What does it do? It cuts what in half? Cuts a segment in half. We don't want to say segment, right? So here's what we could say. Correct. If they're congruent, then they're equal. I just repeated it. If angle measures are congruent, then the measures are equal. Yeah. A point is a midpoint if and only if the point is halfway because you can reverse that. If a point's halfway between two endpoints, it's a midpoint. A point's a midpoint if it's halfway between two endpoints. So you could totally reverse those two statements and it'll always be true. What about all it means that like if I were to say a point is a midpoint if it's halfway between two endpoints, or a point that's halfway between two endpoints is a midpoint. It's just that the reverse is also true. That's all it's saying. Or you could if you were to say two angles that are supplementary apt to 180, two angles apt to 180 are supplementary. It's the same, it's just saying the same thing. Or for angle bisector, you could write like this. So what does the angle bisector do again? Right. So an object that cuts an angle in half if and only if it's an angle bisector. Yeah, so in this case, you could reverse it. Like if an object's an angle bisector, it cuts an angle in half. If an object cuts an angle in half, it's an angle bisector. Both are true statements. No. Well, you say good. It's it's just it's vague stuff. I mean, I'm giving stuff today that's quite vague. It don't worry about it. You'll just be patient. You'll see what will be on there. You'll see. Just keep in mind, this is a very long unit. And also, when we get to proofs, all I'm doing is just giving you exposure to the language. That's all I'm doing. So it's nothing is super. I understand why you said why you're worried about that because it's not a very concrete thing. I totally get that. Um, this is just more just helping understand the language we're using for later in the unit. That's all it is. Okay, one last page, and then we could get started with the quiz and our timings. Nope. So I got to finish this off. Okay, so let's identify the hypothesis and the conclusion. And because I got some cool tools here, I will highlight the hypothesis. Oh, I meant to do highlighter. There we go. I'll highlight the hypothesis in green. I'll highlight the conclusion in pink. Or you can do twice. I don't care. Um, if he's smart, that's a condition, right? Then the conclusion is that you're a genius. Okay. So if the if part's hypothesis, the then part is a conclusion. Now it gets a little funny the way these are worded. RS equals half of RT if S is the midpoint of RT. What's your hypothesis for that one? Yeah. If you're a midpoint, then what? Then RS is half of this. Yeah. Okay. Angle one, angle two implies that angle one equals. So what's your hypothesis for this one? The first part, right? Yeah. So if this happens, then the conclusion is that the measure of the angles are the same, right? And that's a biconditional because you can also reverse it. If the measures are the same, then they're congruent. I think the next one's pretty obvious. That's pretty obvious. And then these are the conclusions. Then this, then this, then that. Because n greater than 8 leads to the fact that n's greater than 7. Okay. We're good? Okay. Next up, provide counterexample. Isha, go ahead.
I did fine.
Sure, go ahead. Yeah, fire away.
If ABC the triangle, isosceles triangle.
Yeah. Yeah, good counterexample. So let's draw, actually. I like drawing. Drawing is good. Yeah, 100%. So AB. So this is true, right? I'm totally making these identical. However, B is not the midpoint of AC. That's because these are not non-collinear, right? So,
Yeah, say it A, B, C or not.
correct, right? Yeah. Or a number that's divisible by 12
8.
if it's also divisible by 4. Well, for example, like 20 is divisible by 4, but not 12, right? Does that make sense? So you're just thinking of counterexamples for that one. Okay. Um, and then lastly, converses. State the converse. Is it true or not? If it's false, give a counterexample. Divisible by 4, but not 12. That's because you're not paying attention. It's 20. Yeah, I'm gonna tease you a little bit. You're not, yeah, it's 20. It's okay. That's a 20. Yeah. Zoo is divisible by 4. Okay, I'm just gonna tease you a little bit. Okay. But we're cool with that. We're okay with that. That makes sense how counterexamples work. Okay.
Yeah.
All right. Okay. Last bit, then we can start the quiz. Our time, the perfect timing. Okay. Okay. So state the state the converse. So today is Friday if tomorrow is Saturday. So if today,
What's the world at?
there you go. Then tomorrow, guys, let's,
Did you just say the same thing?
yeah, it's pretty much the same. It's true. No, because the conditional, so what's the conditional here was if tomorrow's Saturday. And that was the conclusion. So I reversed it.
Oh, I see it.
So I reversed the statements. So today is think of it like this. Actually, I probably should have done this. Let's call this like statement A. And I'll call it statement B. So A leads to B. That's what the original does, right? If tomorrow is Saturday, then today is Friday. So what we're now doing is does B lead to A? So now reverse it. If today is Friday, does it lead to tomorrow being Saturday? Of course it does. So that's true. X is bigger than 0 implies that x squared. Okay. So if x squared is greater than 0, then x,
No.
and that's false. Because x could equal what? Yeah. What if equal -2? Because -2 squared satisfies the condition. Does it satisfy the conclusion?
No.
No. -2 is a great counterexample. Any negative number, right? Because you satisfy the condition now, so the conclusion is not satisfied. Originally, it was satisfied. If I put it back, say, give me a number bigger than 0, 4. Is 4 squared bigger than 0? Great. 100%. That works. But if I reverse it, is it always true? Sometimes not. Not always true. So you can't say true with confidence, right? So there is a counterexample like -2, for example. Then lastly, if a number is divisible by 6, is divisible by 3. So if a number is divisible by 3, then divisible by 6, true or false? False again. Give me a good counterexample. Yeah. Any of those examples. Now, originally, let's say I picked 12. 12 is by 3 or 24. Sure. But yeah, in reverse it, it's not true. So again, this is all just again laying the groundwork for later in the week when we do proofs. So just very simple lesson, nothing too crazy. Dan, yes, go ahead. False because like what if I pick 9?
Oh, that's the.
9's a counterexample. So 9 is by 3, but not by 6. There's a whole bunch of other scenarios that I've heard Kyle or Ishan share. So Yeah, I'm gonna move you guys. You guys proved. Anyway, it's okay. We had a short lesson today. I'm fine with Okay, so what we're gonna do for the quiz, if you guys can, you see those little like dividers on the edges of the desk. So if you guys could put those up, and also I'm probably gonna have you guys also actually, and also can you guys rotate? Can you guys also rotate your desks too, so you guys are facing me? If you can like rotate that. So, yeah. Never rotate me. Pull muscle.
He shot.
Right here. Yeah, that's still in mine.
Oh, there's a wall. With the lines, there's a
Back.
Okay.
There's a wall.
Always see you rotate.
What I'm trying to. If that. Yeah. Like. Let's take a lot.
Yeah.
I'll study when you study. I'm gonna need to study. You have to see harder than that.
Heavy rotate, please.
I don't know, but it's not fair.
That was there. But one of my classes playing with students, so you cannot be smooth like that.
Thank God.
Okay, cool. And then you're gonna go Dan. All right, let's start. All right, so yeah, the rest of the class. I mean, 16 minutes of standard time. I don't think you guys need it. Also, I think that's maybe less. If you look, guys, and you can catch that if you so desire.
Like I'm almost in that.
Was that? Oh yeah, exactly. You know, I haven't had a chance to do that yet.
Yeah.
I don't, unfortunately. Sorry. No question. You guys, let's keep the conversation with Dan, please.
Yes.
Okay, guys, quiet, please. Thank you. And I didn't know the paper. On South Office. Of course. Go. All right. Good luck. And then once you're done, you can start homework. Homework's already in Schoology. It's just a Delta math line. And I will hand out the homework packets just so you guys have it.
How long did this take you to do?
Around 2 minutes.
There's a 5 out of 6, that's what, 2 and.
It's 12.
I just put 60 minutes as an arbitrary number. You got, yeah, about 2.5, 3 minutes.
Yeah, so then.
Most important. Oh, yes, what's some stuff?
You have another research?
I don't, unfortunately, sorry. Yeah, you guys gotta compare. Someone else is borrowing it.